Hello, everyone, and welcome to another episode of Open Observability Talks. I'm your host, Dotan Horovits, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. OpenTelemetry has been gaining wide adoption, and many use it in production. We've discussed it at length in the last episode I had here with Juhasi. But as organizations start using OTel at scale with multiple collectors across servers, containers, edge environments, whatnot, a new challenge arises. Essentially, how do you remotely manage, configure, and update this fleet of collectors in a consistent and secure manner? This is where Open Agent Management Protocol, or OpAMP as we call it, comes into the picture. It provides a standardized protocol that lets central backend automatically configure agents, push updates, monitor their health, and collect status information. This makes large-scale observability deployments much easier to operate and control, and that's going to be the topic of today's episode. So I invited Andy Keller, OpAMP maintainer and also principal engineer at Bindplane, to join me on this episode to tell us about OpAMP, its use case, architecture, project status, and even some hot updates right off of KubeCon newsreel. So stay tuned. This is going to be interesting. And hey, Andy.
Hi.
Great to have you here on the show. Yeah, great to have you. So I tried saying very briefly about OpAMP, but let's start really with even before OpAMP, about the challenge. What are we trying to solve? What has been bothering us to come up with OpAMP?
Sure. So before OpAMP, we probably developed in-house 3, 4, maybe 5 different agent management protocols. Some were HTTP based, long polling. We used WebSockets. We used protobufs. We used JSON. We had lots of different strategies for remote configuring and getting the health status and other ways to manage agents that were deployed. And when there was some interest in the OpenTelemetry community of developing a new protocol for agent management, it seemed obvious that we should migrate to using that. And so we took a lot of what we had learned throughout that process of many years of different custom protocols. And part of the reason there were different ones, by the way, is we had Java agents, we had agent written in Go. And so each time we sort of tweaked it a little bit. But when we started using the OpenTelemetry agent as the basis for our collectors, it made sense to use an open protocol that was being developed at the time. I sort of got wind of it via our engagement with OpenTelemetry. And if you're not familiar with our involvement with OpenTelemetry, we've been contributors for a long time. Probably the biggest thing we contributed was the Stanza log processing engine for logs in OpenTelemetry. But we've contributed many receivers and processors and other components. And we've been involved in the project for a while. So when I heard that other people were interested in an agent management protocol, it was pretty natural to get involved from the beginning and review the initial specifications. And a lot of this, Tigran from Splunk was a huge contributor to the very beginning of it, and obviously still a maintainer and still very, very engaged. But
I want to really, we ran already to the solution and the protocol, but I want to go back to the essence, the problem of scaling out or operating large fleets. So tell us a bit, like, what does it take? What is a typical organization that deploys OpenTelemetry at scale? I don't know, thousands of nodes, or give us a bit of a sense of what a typical deployment at this scale looks like, and then how many collectors would you end up with? And,
sure.
And
what's interesting is there is no typical deployment, and I think many of your viewers are probably familiar with this, but we see anything from a couple massive OpenTelemetry gateways, where really what you're doing is managing the configuration of the gateway and doing all the processing there, and that's sitting somewhere between your edge and your backend. But then we also even see people deploying collectors to embedded devices. We have collectors in point-of-sale machines. We have collectors on laptops collecting Windows events for security tracking. I mean, there's the use cases are many, and but for all of those problems, a consistent part of it is how do you know what that collector is doing? How do you change what it's doing if it's not doing what you'd like it to be doing? And there's a lot of tools for automating deployments of software in general. Chef, Puppet, and things like that, and Ansible, and there's many solutions. But what we've found is that often you want to have that thing deployed and then be able to remotely connect to it and understand how, if it's healthy, if it's configured properly, be able to modify the configuration. And often it's because the teams, what we see in a lot of deployments is that the teams are different. The ones that are kind of responsible for deploying collectors are often different than the observability team, who's really responsible for what those collectors are doing. And so this allows you to really segment that, that
Interesting.
responsibility.
So would you say you gave an example which is very good, because like people know these like Chef and Puppet and other configuration management tools. Would you categorize that as primarily configuration management? Because there is also an aspect of observability, like monitoring the collectors and see how they do, and so how, give us a sense in the terms that we know from other things in the IT industry of what it segments into.
Yeah, well, it's interesting you mentioned observability, because what we've found with OpAMP as it's developed is it started really focused on configuration management, and with agent health and component health and things like that, really moving into this observability for your observability realm, because observability is something that is so critical to operations, that you need to know, is your observability actually working? Am I actually collecting the logs I expect to be collecting? Because if I'm not getting any pages in the middle of the night, it's either because everything's great or my observability pipelines are failing. So the actual health of your telemetry pipelines becomes a big piece of that. And I think it's really that kind of real-time control, and access to, when I say real-time, I mean we're connected via WebSocket to hundreds of thousands, millions of collectors, and when somebody wants to change the configuration, it can happen in the span of milliseconds. Where typically a lot of that tooling is it's just sort of a different approach of whether you're doing this over a real-time connection to the actual binary that's running, and could even just dynamically update, for example, in theory, and we'll talk about that when we talk about roadmap and things like that. But that's really the difference. So just really separate the concerns of deploying the software from configuring the software.
Yeah, makes sense. So it's sort of the control plane of I guess the collectors, and we talked about configuration management was the core, but then again adding the health monitoring and maybe entire life cycle, right? In a way.
And updates, exactly. So there's the packages component where you can the server can specify what new packages are available, and the collector can bring them down. And that includes the collector binary itself. One thing you'll notice about OpAMP is it's part of OpenTelemetry. A lot of the capabilities seem pretty aligned with OpenTelemetry, but it's not intended to be specific to the OpenTelemetry collector. So the packages available capability, for example, really could be used for a collector that supported plugins or supported dynamic downloading of components and separate from the binary of the collector itself. So, but definitely also the collector. So,
and we should mention also Kubernetes, right? The OpAMP bridge is another example, just to show it's not just the collector, right?
Yeah, absolutely. So the bridge speaks OpAMP, and it's actually pretty different the way that works. It's really, rather than communicating with collectors, you're communicating with this OpAMP bridge. The OpAMP bridge is communicating within the cluster with the OpenTelemetry operator. And that operator reads CRDs and deploys collectors. So it could be daemon sets or deployments or sidecars, different ways of deploying the collector within the cluster. So those CRDs are something you could just apply to Kubernetes, or the OpAMP bridge allows you to specify those CRDs remotely. So you could deploy a new collector to a cluster. If you have the bridge and the operator and the bridge installed, I could just put a collector in my cluster, or I could tweak its configuration, and that would effectively change the CRD. And then it's up to Kubernetes at that point and the operator to manage the lifecycle.
Nice. And going back to the collector, I'm wondering, being the techie side of things, and taking something that I guess in a way wasn't really, when we as the community built OTel Collector, we didn't build it with a full control plane architecture and even design elements in mind. So I'm wondering, when you came to implement OpAMP in that regard, things such as a hot reload, all of the things, how you get it to run. Give us what it takes to turn a single collector entity into a fleet in this respect.
Yeah, so we could talk through about the history a little bit. It's pretty interesting. So I mentioned we got involved really early with the specification and the implementation of the library and OpAMP Go, and our initial use for it was really as the protocol to connect our distribution to a management server. So we took our distribution, we modified some of the bootstrapping and made it so that our distribution spoke OpAMP. And as we were doing this, and the way we did it is kind of the way we did it with other collectors we had implemented in the past. I mentioned we had a Java collector and a Go agent that we had built. Was sort of at the bootstrapping level to connect to the server, and when you saw a change, basically just reload the configuration dynamically. And so the way that we did that in the OpenTelemetry Collector is by sitting in front of the service. So the normal kind of command main would launch the OpenTelemetry service. We sat in front of that, we launched it, and we actually shut it down and then relaunched it when we saw configuration changes. What was interesting is for the first, I don't know, 6 months, year, it was kind of whack-a-mole of, oh, the Prometheus port was opened and never got closed on shutdown because nobody really intended anything to happen after shutdown. Shutdown was, it's nice to clean things up, but really we're going to shut down this process anyway. So we had to be really deliberate about cleaning things up, closing ports that were opened, and we just kind of went through this process of figuring out all of the different issues there were with hot reload like that. And when I say hot reload, it's really shutting down the pipeline, draining all the pipelines. You shut down the receivers. You let everything flow through the same way it does a clean shutdown now, but it's waiting for that and then building a new pipeline afterward. So that was really, I think, probably the first real kind of commercial or use of OpAMP in the project, because at the time it was something that we were interested in, and Tigran was interested in, some other people, and over time there's been a lot of different companies involved in this, but we just kind of put it in our distro, and then there was some work to build the OpAMP bridge for Kubernetes. And so that was really probably the second use of OpAMP, but the first one that was really part of the OpenTelemetry project. And it really wasn't until probably like 12, 18 months ago that we have the architecture with the OpAMP extension and the OpAMP supervisor. And these are in the contrib repo for the OpenTelemetry collector and are really kind of the way things will be done in OpenTelemetry. I say the way they'll be done. We'll talk about roadmap some more, but that's also, there's other opinions about how this could be done. And so there may be other implementations as well, but that's really kind of the idea of how this works in the collector.
So let's really delve a bit into that. So first of all, there is the protocol that you mentioned, and there's the sort of implementation element. So give us this distinction between what's the OpAMP as the protocol, what's the implementation, and maybe a bit about, you threw a few names of components, maybe a bit the component architecture so that people can start getting a sense of that.
Sure. So these are both in GitHub under the OpenTelemetry project. There's the OpAMP spec repo, and that really just is the specification.md file. It really is a description of the protocol, all of its capabilities. There's really just two messages. There's a server to agent message and an agent to server message, and it describes all the components of those messages. There's protobuf for those, and like I said, really a description of the specification, no implementation. And this could be implemented in any language that supports protobufs, which
once you have protobuf, you can generate your own SDKs, your own clients. It's it's open-ended.
So then the related repo is OpAMP Go, and that's the Go reference implementation of the specification. And that includes both a server package and a client package. The client package is can be used in the collector, and it is used in the collector. And it's also used in the supervisor, and I'll talk about what those actually are. But so there's a client implementation, and it actually does a decent amount of work in terms of kind of state management. So when you send out a configuration, it determines if that configuration is different, and it has a callback mechanism where it reaches out to the collector and says, we've got a new config, and the collector responds, and then the client, constructs the appropriate response messages. And so I wouldn't say it's a heavy client, but it does a decent amount for you. The server implementation is a little thinner. It's really, it gives you some callbacks when you receive messages over the WebSocket or via HTTP. But they're pretty simple. It's like, on connected, on message, on connection close. I think there's an on error callback. It's not like there's a whole lot going on. It's a little bit of an abstraction from, a raw WebSocket connection. So those both live in the OpAMP Go package, and then that package is used in the OpAMP extension and the OpAMP supervisor. And so the extension is an extension, as as the name would suggest, a component for the collector, and it implements sort of the read-only half of OpAMP. So it will report the current configuration, it will report health status, but it doesn't accept any changes to configuration or any changes to packages or anything like that. It's strictly read-only. And so that component can be configured as part of the collector. As part of that configuration, you say what remote server you're talking to. And you could have, with just that extension, a management server that really is more of an observability platform, because it's really just, you can see the configuration, it can see the health, you can see that it's connected to the platform, things like that, but you can't really change anything. The supervisor then is the thing that implements read and write. And the architecture is pretty interesting in that it implements, or it uses the OpAMP Go library as well. And it has both an OpAMP server and an OpAMP client in it. The OpAMP server communicates with the extension in the collector. So it kind of sits between the management platform and the collector. It speaks to the collector on behalf of the management platform, and it can accept changes because it's a client to the management platform. It can accept changes. And what it does is a separate binary that will actually write out a new config to disk, shut down the collector, restart the collector with a new configuration. And it does some other things like make sure the collector starts. If it doesn't start, it will revert the config and run with the last known good config, so that we're not breaking your telemetry pipelines remotely, because that's part of this is to be resilient and to be able to manage this remotely. You want to make sure everything's still running. So
underneath the hood, it's ultimately a restart. So it's loading a configuration, restarts. There's no
exactly.
sense of
So it's a clean
real
shutdown,
hot.
process ends, and exactly.
Gotcha.
And again, there's other ways to do this. We can talk about those things, but that's
a current architecture, and then that's as we said, this is separately from the spec. So the spec defines the protocol essentially, as you said. Like people know, I don't know, OTLP is another protocol under the. So this is the pure protocol, and then there's the OpAMP Go and these additional components. So all of these, of course, under the OpAMP GitHub.
Exactly, and I should mention that the bridge in Kubernetes, the OpAMP bridge also obviously uses the OpAMP Go library. So the library is used pretty heavily within anything in OpenTelemetry that's using these components. One thing I just want to say about this supervisor and extension architecture, one thing that's really nice about it is it doesn't really disrupt the collector core in any way.
It's a separate process, right? It's a
separate process that runs separately from the collector, and it relies on an extension, which is just a component that the collector can optionally use. So it's not really, for better or worse, because there's other cool things we might be able to do, but it's really not digging into the internals of the collector or the internals of the pipelines. It's really kind of operating at a higher level, which allows all of this capability to exist with the collector that didn't really require any changes to make this possible. So that's pretty powerful. And I think part of, if we kind of go back to the beginning of that history, when we were originally working on this, there was some interest from the community, like, oh, that's cool, but not like this, not what we're seeing today, which is lots of people are implementing OpAMP in their telemetry backends so that they can remotely configure agents and collectors. And there's a lot of enthusiasm in the community for OpAMP. So that's why we're seeing more adoption in the OpenTelemetry like upstream, and then I also think that's why we'll see some other things in the next year or two that will really dig in a little bit more and unlock some more capability. So
nice, and maybe a word about the what it looks like in terms of the deployment architecture. So how it's so as you said, there's a separate process that sits alongside the collector, but how do you deploy it? How do you deploy them maybe together? What's the relation? What are the different options that we have there?
Yeah, so you would deploy the supervisor and the collector together, kind of one-to-one. The supervisor will automatically configure the collector to speak to its server. So I mentioned the supervisor has a server. The collector extension is an OpAMP client. And so when the supervisor receives configuration, it will add in the configuration necessary for the OpAMP extension to communicate with the supervisor. So, typically you would deploy that maybe with some base configuration that you want to start with, and because that'll be reported up as the effective configuration for the collector. But then you would start changing that configuration remotely via OpAMP. There's a couple different ways to package it. If you're using sort of standard package management tools in the operating system, you would usually deploy the supervisor separately, but there's and point that you need to reference in the configuration of that the binary of the collector. Normally those things would be in kind of standard locations, but there's different ways of doing that.
Okay.
And then in
yeah.
Kubernetes, when you're in a containerized environment, really that's where the bridge comes in, and the operator really being in charge of deploying. And there it's pretty different because, like I said, we're the operator is capable of deploying. You create the CRDs, and that will deploy the collectors, and the supervisor is not involved at that point.
Okay, but anyway, it's the option of the Kubernetes operator. It's important to know that, and in terms of the models, a lot of whether it's deployed as a daemon set, sidecars, all the different options that you have there.
Yeah, those are all options in the CRD. So
all of them are
CRDs. It's a custom resource definition. There's one just called collector, and it has in the spec, it has the config, but it also has a bunch of other things like a mode, which indicates how that should be deployed. And that's where you say if it's a daemon set or deployment, and then kind of all the normal Kubernetes things you would expect, replicas and auto scaling and, image pull policies and credentials, and, basically it's the whole, set of options for deployment. So
yeah, and then so you mentioned the OpAMP Go as the reference implementation. I'm curious, are there any other interesting implementations of the protocol that
there is? So so it actually started I'm trying to think back, like 3 years ago, there was a Java implementation, and that got resurrected. I don't know if it got fully resurrected or rewritten, but about a year, maybe a year and a half ago, as part of the Java SDK. So I don't know exactly the maturity of it right now, but the Java SDK, as I understand, can right now speak OpAMP and receive remote configuration. There's limits on what can be configured, and it's really you're kind of in a different situation when you're in SDK, because we're not going to shut down your applications to reconfigure them, so it really the SDK has to really do the management of the configuration, and it has to be a hot reloading situation, right? So but that I don't know a lot about it, but if you want to look into it, somebody's interested, the Java SDK,
the Java SIG, I think that would be the perfect place for folks.
Exactly.
The Java folks out there, if you're interested, the Java SIG would be the right place for you to join on the conversation for this and other things that are related to the Java SDK. But it's interesting because
I think we'll see that continue in the future to other SDKs. I think this idea of remote management is really powerful. You can just think of some use cases are somewhat trivial, but let's just take sampling, for example. You might just want to change your sampling rate.
Exactly.
Or you might be trying to investigate an issue and you want to turn on debug logging. It's pretty powerful to just be able to do that remotely. So,
and across the cluster, again, doing it at scale. So if your microservice application with multiple tiers and data stores and whatnot in your architecture, and you need to do that now across the whole system, across the tiers. This is something that's very powerful to do that in a click of a button. And also, I think it shows something, going back to a note that you said briefly before, but now maybe people understand it better, that the protocol is larger than just the collector. So the collector is the primary implementation, but the protocol is meant to be more than that, or more generalized than that, so that it can serve other types of agents. This is why it's called the agent management rather than the OTel Collector management, because agent could also be SDKs, and potentially, I think the protocol can definitely be generalized to other types of agents as well, right?
Yeah, and that's really, as I mentioned previously, with the messages being kind of generic, it's not. we're not opinionated on the format of the configuration. We know what an OpenTelemetry configuration looks like. An SDK configuration, by the way, looks different. So that's just within the OpenTelemetry community. You have different configuration, but then you might have other agents that have completely different configuration styles, and you still want to be able to support them. So the remote config message that's defined in OpAMP is really just a map of name value pairs where that value can be anything. And then it's really up to the agent to just see, okay, I've got a new value. What is this? And like the bridge sees a value, and that value is a CRD. But the supervisor sees the value, and the value in that case is a collector YAML. So, but I think we would love to see other agents, whether they're security agents or other observability agents in the marketplace, implement OpAMP. It's definitely not intended to be an OpenTelemetry specific protocol. It just really came out of some interest in this community, and it was a convenient place to house the project. But really intended to be agnostic from the agent.
And it's interesting because I think keeping it generic enough is not just about a generic payload, because the sense of configuration changes between components, between, let's say, SDK and controller. Also, the approach for loading it technically is different, right? When you have an SDK, for example, you talked about supervisor doing this restarting or shutdown. Obviously, this is much less applicable for SDK. So it's also in the terms of the mechanisms being applied. In order to support a variety of types of agents, you also need to support a variety of mechanisms, right?
Exactly.
So today, for example, for the SDK, so it works differently. And what you described about the supervisor probably is not the way that you do it with, with the SDK, right? So just to make for those worried SDK developers out there, it's the mechanism behind it is different.
Exactly. And I guess the one thing I should mention is some of the auto instrumentation support available with the Kubernetes operator is really powerful. So, and that also allows you to implement observability for your applications in a really lightweight, non-intrusive way. So, and that can also be configured, via the OpAMP bridge and configured remotely. So, while we'll see SDKs themselves start to speak OpAMP more, there's already this ability to inject auto instrumentation, which is powerful.
Yeah, that's nice, and also good to know that. So it's total. So we have the OBI essentially. So today it has the interoperability with OpAMP, you say?
Well, the Kubernetes operator is capable of doing that via the OpAMP bridge. Yeah.
Okay, makes sense. And another question about so we talked about the server side, and I'm wondering, are there different server implementations out there? What can we see? Obviously, you have one, but just to understand, what can people find out there when they look up OpAMP implementations, I guess?
Yeah, I think there's a couple open source projects that are pretty small, and I think not really full featured, but I think there's some interest. It comes up in the OpAMP SIG quite often, some interest in developing a reference implementation of the server. I think I would almost compare it to if you think about OpenTelemetry as a collector of telemetry, and also a way of implementing pipelines for telemetry, there's not a backend as part of the project. There are lots of open source backends, but this is the way we send telemetry data to other things. I really see the OpAMP project as a way we define how agents can be managed, but it isn't part of the project to manage them, if that makes sense. So I think we'll probably see some of those servers developed. I do know that there are commercial backends that speak OpAMP and are implementing that within their platforms. I think we might be the only vendor neutral. Bindplane is kind of unique in that we really manage telemetry pipelines and don't. We send telemetry to any backend. You might send some to one company and some to another company and some to, some other storage or something like that. So, but there is a very small server example in the OpAMP Go repo. And it's really just kind of to give you an idea of how this works and to explain how you would implement a server. I think there's a lot of, it looks really simple on the surface because it defines sort of a contract between one server and one agent and how I would deploy a configuration to that agent. The protocol isn't opinionated about if you have 100,000 agents, how you deploy that configuration to 100,000 agents. Do you do one at a time? Do you do 10 at a time? Do you, do one, then 10, then 100, and exponentially grow until you've deployed it to all of your collectors? I think there's a lot of nuance in how to do that effectively at scale.
So how do you see people? I'm not about specifically now customers, but in general, when you see people even coming to the SIG and showing interest as end users, how do they consume? What do they do? How do they get started? So they get excited the fact that there is standardization around that. But what's the next step? Take us to the really the first steps for people starting to play around with it and to try and implement that.
Yeah, I mean, I think to be, to be honest, at the moment what we're seeing mostly is vendors in the SIG meetings. Elastic is there, and Dynatrace, and Google, and Splunk, and Honeycomb, and I'm probably leaving lots of people out, but we see a
an
lot
impressive
of
list, and it's great to see that that backing of so many important, significant vendors. So it's great to see that.
Yeah, but there isn't a lot of. I think in terms of end user usage, a lot of it is really. I would say it's defining a capability for collector management, for agent management. But for an end user, it's just going to be a capability that they see in the platform that they're using, and they aren't really thinking about adopting and implementing themselves. Now, one kind of fascinating caveat here, maybe that's not the right word, but at a KubeCon in Atlanta, Nike did a presentation. You can find it on YouTube. They implemented their own OpAMP backend, and I thought that was pretty cool. So yeah, they read the spec.
If you're big enough an end user, you also do that yourself.
Yeah. And I have seen that with, we've talked to companies who have very special use cases. We have some companies that are using our platform, for example, really as just an API layer. So they've implemented their own management UI and kind of experience, but they're doing the management via our product, via OpAMP.
Nice.
And the reason we're kind of sitting in the middle is because of a lot of those things I mentioned, is doing this at scale, supporting, rollouts in different ways, and, and helping with the configuration process. There's a lot you can do there. Yeah. So.
I want to ask maybe about also can you tell us about the state? What's the maturity state of the project in terms of the scale, the CNCF scale?
Yeah, so the spec is officially beta, and the way we decided to do it is, if you'll see in the spec, if you read through the spec, different messages. Now, I said there was really only two messages. There's a server to agent message and an agent to server message. Well, within that message, you have sub messages, and each of those sub messages has a different maturity level. And so some are in development, and I would say like the config management and the agent description that kind of just describes some agent metadata. Those things are beta. OpAMP Go implementation is also beta. And then I think, I'm not sure what the, I'm going to look real quick because I'm curious, but the OpAMP supervisor and extension are considered at this point. But I would say they're fairly new. And I don't see it right away.
It's okay. We don't have
Yeah.
to. But in general, I think it gets a sense of the maturity of the project, which
Yeah,
also
it's considered
diverges between
considered
different.
alpha at the moment, is what it
Yeah.
says. Yeah.
Sounds good. And I have to say, I came back from OTel Unplugged Europe that took place in February, just recently. And it was very interesting for me to see that OpAMP was brought up, and there was actually enough interest to merit a session. So it's a non-conference, so the sessions are determined by the interest expressed by the participants. And it was very interesting to see that OpAMP was brought up and drew enough attention. So I think, first of all, very, very encouraging. I was very happy to see that, and also and I think interesting points that came up. I know that you weren't able to join, but I'm wondering if there's anything that drew your attention afterwards in terms of the discussion that took place.
Yeah, I wasn't able to be there, and I will be at KubeCon in Amsterdam, so looking forward to that. And I was in Atlanta, so that was great. I think we're seeing a lot of interest. I gave a talk last year in London about scale, about operating OpAMP at large scale. And that was kind of a successor talk to one I gave a couple of years ago in Chicago, which was really just introducing the concepts of OpAMP. Those are both on YouTube, by the way, if anybody's interested in learning more about go through slides of what the messages all look like, etc. But I think people have really come around to this idea that remote management is a critical at scale for tens of thousands or hundreds of thousands of collectors, and I think they're excited about being able to observe their telemetry pipelines from a single pane of glass, as opposed to a bunch of files in some Git repo that they're expecting their CI process to automatically deploy for them. It's nice to just sort of see things operating. And what kind of questions were you hearing?
So I think that a lot of that was just about putting it to practice, like people wanting maybe more. We talked about before, and you said that it's part of the definition of the project, that it's the protocol and some reference implementation, not something that you should download and start running. But when people want to start using, they're looking
Right.
for some sort of an OpAMP server, and they can use, or also in terms of the being able to use a UI, all these things that are more about the usability, which is goes to the productization of things. It's beyond the scope of the project as a project. So there is some sort of a setting of expectations. Some of them is more about, I guess, getting started guides, things that can, as an open source project, and I'm sure that it will be part of the requirements for maturization of the project in the CNCF scale. But these are the things that usually the project will OpAMP included will need to enhance. So this is the limit, I guess where the line draws between enabling the getting started and all of the documentation around that, and samples and all that, and the other part is something that I would, I guess, call productization. That obviously when they reach this point, they need to decide whether they do it themselves or whether they turn to someone who productizes for them.
It's a great kind of distinction of the product versus the protocol. I mean, if you let's think about HTTP as a protocol versus a product, right? There's no product there. There's you need a server, you need a browser,
Exactly.
So I think to the extent that we've been able to put the collector as a product, as something that speaks OpAMP, I think has been the focus at the moment of like getting And like I said, we'd love to see more collectors. I think really anything out there, especially with the supervisor. I think the supervisor is a model that, because it's just writing a config disk and restarting a binary, that binary could be anything, right? So we can easily see other collectors out there speaking OpAMP. On the backend side of things, I think surely there's interest, and I've heard people, looking for a backend, and I'm sure there will be some built. But really the project within OpenTelemetry at the time is focused the spec itself, the reference implementation, and then how do we activate this within the rest of the OpenTelemetry community, when the collector and the SDKs and the operator. And I really kind of try to play both sides, where it's I'm mostly focused on the protocol, but I'm very keen on getting the implementation into the collector.
Yeah.
And I also want to support vendors that are looking to implement this in their platforms. But really, I'm sort of laser focused on protocol, its capabilities. What are we missing? What can we add to it? One thing that was I'm really happy with how it came out about a year and a half, maybe 2 years ago. We added a concept called custom messages, and it's really a way to extend the protocol so that you can make this protocol do, you can use the protocol to do different things. So we'll see, vendors in their own distros implementing custom messages. There's actually, I think it's an S3 exporter that actually, I can't remember if it's the receiver or the exporter that speaks custom messages over OpAMP, that'll actually give you the progress of, I can't remember if it's reads or writes to S3, but somebody implemented that within their component.
Dotan.
That was pretty cool.
Yeah.
So
That's
it's just
S3. That's not a negligible. That's
because one of the cool things is that the OpAMP extension actually gives you a hook to send and receive custom messages, so that any component within the collector can use that hook to then send and receive custom messages. So if you have a custom component that does this particular thing, and then you have your server, knows to send these special messages, they'll get routed through the extension to your component and routed back out. And it really opens up a lot of pretty cool capabilities. So.
Nice. And I guess talking about extending the capabilities is a good segue to looking forward. I think now, as we're heading towards KubeCon Europe, you're going to have a big launch ahead of KubeCon, hot off the press. So happy to give the stage to the big thing about OpAMP Gateway. Do you want to say a word about
Yeah, so one of the things I've been working on is this thing we're calling the OpAMP Gateway. It's currently implemented as an extension, although it's probably going to be refactored into a library that could be deployed as a binary or something else. But what it really provides, if you think about a gateway deployment of a collector, is effectively relaying OTLP data. So you have a lot of edge collectors, and they're sending into another collector via OTLP. Then they're doing some processing in the gateway. Then that is sending to one or more telemetry backends. What the OpAMP Gateway does is really similar, in that you might have a lot of edge collectors that want to speak OpAMP and want to be remotely configured and want to report their health. And but one of the challenges today is, if I have all of these collectors and they're connected via OTLP to this gateway and they're sending telemetry, they might not be able to see outside the network. And what we require right now with OpAMP is that each one of these edge collectors connect to the management platform directly with a WebSocket. And so what the OpAMP Gateway allows you to do is that be the server, the OpAMP server for all of those collectors. And then that maintains one or more upstream collectors. And you can configure how many upstream, upstream WebSockets. And you can configure how many WebSockets you want to use based on how much traffic you have and how many OpAMP messages you expect to be going across. But instead of, let's say I've got 100,000 collectors deployed across my many different clusters in my organization, instead of all 100,000 connecting to the management platform, I can deploy 100 OpAMP gateways, have 1,000 collectors connect to each one, and then those 100 connect to the management platform. It really helps with one of the limitations of one of the scaling challenges of the management backend is really just maintaining a ton of WebSockets. If I have 1 million collectors out there, now I need 1 million WebSockets. And so this really introduces the ability to multiplex these messages through the gateway. So this is something that I've been working on for a few months, and it'll be in our in a contrib repo of our distro, and if people are interested, we'll be happy to donate it upstream. But that's where it'll start out. So, and we should be ready within by the time this is announced. I'm guessing the repo will be available, so I'll give you a link to it so that people can find it.
Yeah, for sure. We'll put it on the show notes. And you mentioned some figures just to understand. We started by even the OpAMP protocol itself by scaling challenge, and now you're talking about another order of magnitude or more of scaling. So what kinds of scales? Give us a sense of the deployments that you see out there at scale for
millions. I mean, if you think of, you start thinking about like an IoT space, an embedded space, that's where you really kind of unlock these really, really high numbers. Some of the bigger ones we see are security, use cases with like workstations and things like that. We see point of sale machines I mentioned. But when you kind of get into the embedded space, that's where you really see like millions of being a number that you need to start reasoning about. So, and yeah, it is, but it's and so again, that this gateway will not require the backend to really maintain millions of live WebSocket connections. So that's really where we see some scale challenges. But the WebSockets are great for low latency. When they're dormant, they just kind of sit there. It's a great way to communicate remotely with the agents. And the OpAMP protocol also allows for HTTP, so it's very similar. In terms of the protocol, the way the messages flow is really similar, but it's, and kind of a HTTP message up to the server. The server can respond, the agent can send another message, and the disadvantages of the server can only send a response when the agent sends a message. So the server can't really push, but if the agent sends messages pretty frequently, then you get something pretty close to push with a little latency. But
yes.
Yeah.
And then I have to say, also zooming out, it shows. I started in my opening notes about the maturity of OpenTelemetry as a project, and I think seeing the project with OpAMP as the enabler, but in general, seeing OpAMP deployed not just in production, but in production in these scales, give a sense to those who are still debating whether the project can sustain production workloads. I think these figures that you just described.
I probably can't name names, but there's a good chance when you're checking out somewhere shopping, you might be using an OpenTelemetry Collector. An OpenTelemetry Collector might be involved. It's pretty wild. It makes a ton of sense. I mean, the observability space in general has really grown over the past 10 years since I've gotten involved in this space, and it's just, I think people really recognize how critical it is to understand what their workloads are doing, and gone are the days of a black box with a blinking LED on it. We need to see.
That's why I called my podcast Open Observability Talks. It's all about open observability. That's not black boxes, and it's not proprietary. That's the way to go. And I want to maybe as a important note towards the end is about the roadmap. So this is a major release. The OpAMP Gateway, I think, is as you explained very nicely, and this is it's coming your way. Probably the link will already be in the show notes, so people can try it out. Beyond that, what's up in the roadmap for OpAMP?
Oh boy, there's so many things. So I mentioned the probably some more SDKs. Adopting OpAMP. We'll see how that goes. I think there's a lot of discussions in that space. I think there's different flavors of sort of hot reload and partial reloading, and there's some actually at the OpAMP SIG meeting today, which we while we're recording this, we had 2 hours ago, we had our OpAMP SIG meeting, and there were actually 2 different proposals for different ways of configuring agents. One was really about sort of a partial reload of pipelines. So can we just, if we have 10 pipelines in our collector, and I only change the configuration of one, can I leave the other 9 running and just change that one collector, or that one pipeline? So that would really be a change within the core collector, but that would then naturally lead to OpAMP managing that change. Speaking of the change, I think one of the things we'll see is of diff support with configuration. Right now, the way OpAMP works is you send down a complete configuration, and we've seen configurations get extremely large and complex. So it gets to the point where you don't really want to send the entire configuration down when maybe a sampling rate changed or something like that, right?
Yeah.
So, and I think that also kind of speaks to that partial reloading. And then there's also, hot reloading is something that there's been, depending who you ask and when, varying interest in the community. And, it does respond to a SIG up now and reload the configuration, which is pretty cool. And so there's been some interest as well in taking kind of an approach like we had in our collector very early on, of actually embedding in the collector and not requiring a supervisor, and actually doing OpAMP with that sort of hot reload. There's a really cool OTEP right now that's in the works. The title of it is Telemetry Policy. Policies are intended to be slightly different than configuration. So policy might be, when I see this kind of log message, filter it out, or when I see this kind of log message, add this attribute, something like that. And how that actually results in configuration is, kind of remains, that's kind of up to the implementation, I guess I would say. So then you communicate policy, and maybe the SDK would implement that policy one way, and the collector would implement that policy a different way, but the policy itself becomes the vehicle for communicating the intent. And naturally, you'll see OpAMP want to be a way to deploy those policies. So anything that's really sort of configuration adjacent, I guess, is and lifecycle adjacent, and let's see. I think there's also an effort. In fact, something we talked about at length today was, what our roadmap to stability looks like. So getting the protocol stable, the reference implementation stable, and obviously this is happening throughout the OpenTelemetry community with the collector itself and different components.
Yeah, for sure.
But getting the extension stable and the supervisor and the OpAMP bridge. So there's lots of different things focused on there as well. So.
Great. So I think it's as we're coming to the time. Maybe for the last note, where can people follow the project, get involved, catch up on the roadmap, chime in, try?
So really a great place to start is the CNCF Slack. So, as most of your viewers probably know, that OpenTelemetry is a second largest project in the CNCF. And
what's the name of the main channel? Give us just the names of the channels.
OTel-OpAMP. So
simple enough. And for those who are not yet there, just know it's open for everyone. You don't need to be a paying member or any other thing. And if you go to cncf.io and you look for the Slack invite, it's very simple to join the instance. And then You open your profile, and then you look for the interesting channels. In this case, the OTel-OpAMP. And also, where can people maybe follow you? Obviously, you're there on the Slack, but other than that, how can people reach out to you after the episode?
Yeah, so my GitHub handle and my Twitter handle are both Andy Keller with no E at the end, so ANDYKELLR. I thought that was really awesome once upon a time, partly because Andy Keller was taken, but partly, it's like Flickr and Tumblr and all the cool internet things. And unfortunately, people put the E in all the time. So if you want to find me, don't put that last E in.
Sounds good.
And then and I would encourage you to go check out the repos as well. So OpAMP-spec and OpAMP-go, both in the OpenTelemetry GitHub organization. Open issues, start discussions. We certainly welcome everyone, and we had a good turnout at our SIG meeting today. We have our SIG meets every 2 weeks, Tuesday at noon Eastern. So we try to position it in a way it's maybe a little inconvenient for my lunchtime, but it's very convenient for Europe and the West Coast. So
sounds good. Yeah, and well, maybe last note, we mentioned that briefly. So we're coming up to KubeCon Europe, taking place in Amsterdam, March 23rd through 26th. So a great place to see Andy. I'll also be there if you want to see me as well.
Yeah.
But definitely a good place to catch up with the OpAMP folks, with other folks of the OpenTelemetry. Actually, there's an observatory booth, so a mega booth there that you can find specifically for
it's a great
everything OTel. So hang out there, and you'll find everyone who's involved in anything in OTel there. And there's also, again, since we're at Open Observability Talks, there's going to be amongst the different co-located events on the first day, or day 0, as they call it. There's also Observability Day. I'll also be there. I'll be on stage also speaking.
My favorite day. Highly recommend
it. So highly recommend. It's a good warm-up to the main KubeCon. So come a day earlier, join the co-located event, specifically the Observability Day. Again, a great place to hang out with folks that are observability professionals. And with that, I'd like to thank you again, Andy, for joining me on this episode.
Yeah, thanks for having me.
Yeah, it was great. And thank you, of course, for all our viewers and listeners for joining us on today's episode. As always, all the episodes are available on your favorite podcast app or on YouTube, so you can check it out. And of course, we'll put on the show notes the references for Andy and of course the show. You can follow the show on Blue Sky, on LinkedIn, on X, at OpenObserve, to catch up on the episodes, to carry on the conversation, to ask your questions, to share your feedback, and see you on next one's episode. Until then, may the open source be with you.